Hi everyone, welcome to my talk that is called Testy, a minimal testing tool designed for teaching. A little bit about me, my name is Nahuel Garbezza, I'm a software engineer from Buenos Aires, Argentina. I like to make high quality software. I work at a company called 10 Pines, and I'm also a teacher. I teach object-oriented programming and test-driven development. Well, I'm going to share you a tool. So first of all, I wanted to share you how the tool was born in the first place. I had a challenge 3 years ago. I was about to teach object-oriented programming using JavaScript. I've been using Smalltalk for the last 6 or 7 years, and this was the first time that I added JavaScript to the syllabus. The topics were object-oriented design and test-driven development mostly. And one thing that I always do in all the courses that I do is to make sure that I have the right tools to make sure that the concepts that I'm presenting are easily adopted and I don't have too much complexity on the tools that I'm using. So that was the whole mindset. So this is how a tool like this was born. One day in a class 3 years ago, I ran out of exercises and I thought, well, what can be my next exercise to practice with my students? And I was inspired in a Ken Beck's idea. I started to implement our testing tool with my students in the class with like a mob programming idea. I didn't know exactly what the result would look like, but we started from the very beginning, which is the assert. So the most important part of a testing tool is the assert function. I even made fun of that, and I was tweeting, "Oh, I'm building a new testing framework," and that was just an assert function that you can see it from the tweet. It's just a function that takes two values, compare, and if those are equal, it responds okay. If not, it responds failure. That was like the walking skeleton for the tool. That was the seed. All the next functionality was built on top of that small function. We use that for do some sort of automated testing with our students. Of course, this is very limited, but this is how we started. Then I continued developing this tool. We started using it on our classes like any other testing tool that you might imagine. When I was starting to do that along the course, I started to build a vision. Why do we need another testing tool? What do I want for this tool? I knew from the very beginning that I wanted to build something simple. And like a source of inspiration is this article called Design Principles Behind Smalltalk that I truly recommend you to read it if you haven't read it yet. It's a great piece of our computer science and software engineer history. If you don't know about the Smalltalk, you should read it too. I truly recommend all the history to truly understand object-oriented programming and simplicity in general. Most of the ideas that I try to reflect in this tool are from that article. What do I mean by simplicity? I can identify three aspects that can make my software simple, and this tool in particular. This is a testing tool that doesn't have dependencies at all, which if you compare it to other testing tools like Jest, if you install Jest from the very beginning, you will have more than 300 dependencies and 42 megabytes on your node modules. I didn't want that for my students because we needed to use the tool for very simple exercises and code katas. I even wanted for this tool to be able to be installed in places where the internet connection is not good. So that's why the tool is just a few kilobytes and no dependencies at all. It should be fast, it should be easy to install and configure. That was the spirit. Another thing that I wanted for this tool is that all the code should be understandable. There should be no dark magic behind this tool, which sometimes we see in frameworks and libraries that we are even afraid to go and take a look at the code because we don't understand it. Is too complex. One decision that I made from the very beginning is to not use metaprogramming unless it's strictly necessary. So if we look at the code today, there's no metaprogramming usage. There's no need to do that. I wanted for students to take a look at the code, understand it, and even modify it if they have the knowledge to do that. Another thing that I wanted for this tool is to not have too many features, just have the set of features that I wanted. And it's not the idea to do a copy of all our testing tool. We are started from the very beginning, like I showed you before, from an assert function, and then we build all the features on top of that. As I mentioned earlier, my inspiration was Ken Beck. In the Test-Driven Development by Example book, which is one of my favorite books, and I recommend it to read. Kent starts implementing a testing tool using TDD. So it's like implementing and testing their own tool in the same process, which is very mind-blowing because it's how you can test something that you already don't have. But if you read the book, is brilliant. I tried to do the same on this tool. Every feature that was added was implemented using test-driven development. That's why the tool today has a very high percentage of test coverage, is beyond 95%. That's the spirit. So the tool was initially built 3 years ago, but I have been developing it to add in more features, correct bug, and try to make it usable for my students. I basically got feedback from them and from even myself using the tool and build improvements on top of that. So today you can check the code in GitHub, and it's downloadable using npm. The current version is 5.1. I'm planning to make a new release soon, so stay tuned. And it's very important for me to have this project built in a way that everyone can contribute. So the open source aspect of it is very important to me. That's why I try to do my best writing documentation about how to use the tool and how to contribute if you want to. Also, there are documentation in English and Spanish because my course is in Argentina and it's all in Spanish. I also added issue templates, PR templates. If someone wants to report an issue, they will come across this template to fill. Every change that is added to the tool is documented in a changelog. The project also uses semantic versioning to know which releases are breaking and which ones are from new features and what others are just bug fixes. And that's very important because for me it was the first project where I started getting contribution from people. I am very thankful to 13 people that have contributed as of today to this project. I think that making this effort to build documentation and write a nice backlog with issues, and especially good first issues that are tagged in the project, help people to contribute on the project. And yeah, I'm really grateful for that. That's all the open source spirit of that. One thing regarding that aspect of contributors that I recommend if you're building an open source project is this all contributors bot, which is a very good tool to recognize contributions. It makes you a section on the README where you can display all contributors' faces and profiles, and it's a way to build a community that right now is small, but maybe one day it could be large. Regarding the tool itself, I wanted for this tool to have assertions, which is the most important thing, and also a way to describe different tests, and also a way to group test in test suites. That's the only thing that I wanted. I didn't want something more complex than that. The assertions are written in a fluent interface style that we are going to see in the demo later on. The idea is that you can check for object equality, for inclusion in array, exception raising, and some common scenarios that we face during testing. All the output from the tool is written in a console with color outputs where you can see errors, failures, and things that were okay. It's also multi-language because I wanted the output to be in other language as well. Right now, English and Spanish, but it's configurable to extend more languages in the future. And there's a feature for marking tests as pending, as many other testing tools have this idea of marking a work in progress type of test. These two configuration parameters that are the fail fast mode and the random order, that are, the first one is to making sure that all the process stops at the very first failure if it's enabled, and instead of running all the tests and report all the potential failures. And the random order, which is a setting that I recommend it to enable by default, is this idea of running the test in different order every time, in random order, and that makes sure that your tests are independent, which is a very good sign, and it's a good practice for your test to be independent. So if you want to enforce that, you can enable the random order setting, and all the tests will run each time in a different order. So far, those were all features that every testing tool might have, so there's no difference between using Jest or using Mocha or using this tool. But there are two things that I haven't identified in other testing tools, and I wanted for this tool because I think they are beneficial for students. That's why I mark them as unique. Maybe there are other testing tools that do that, but I'm not aware of that. The first one is that if somehow you run a test and the test doesn't run any assertions, that is an invalid scenario. That shouldn't happen. You should have at least one assertion. So if that happens, usually most testing tools will report the test as success because there are no failures. That's the usual interpretation. But for this tool, I tried to make something different. In that case, I raise an error. The error message says the test doesn't have any assertion. That is an invalid scenario. So if students make that mistake while they are learning to test or to make TDD, they can have the feedback and say, oh, I need to write an assertion for this test. That's one thing that I wanted for this tool. Another feature that I added because I also saw that problem and see how can I make this tool to report feedback, proper feedback to the student, is this idea of comparing undefined with undefined using an equal comparison. I'm going to show you why is there a problem in the demo, but the current behavior in the tool is that if you compare undefined with undefined, it will give you an error because it's like an undetermination scenario. In case you really want to test if a value is undefined, there's a special assertion for that, which is undefined, that is also built in the tool, that you can use for that. And going back a little bit on the simplicity aspect, I wanted to talk about how to control the complexity, because once you keep adding features and keep adding code, eventually the tool might become complex. So can you control that somehow? Well, I don't have the right answer for that. What I do is to look for different things, look for patterns in the code, look for some quality metrics like code complexity or lines of code or technical debt ratio. But one visual hint that helped me to control the complexity is this idea of module chart. So in this chart, I'm displaying all the modules that are in the tool. As you can see, there are less than 20, the dependencies between each other. So if I implement something and generate the graph for that and it's too complex to understand, that means that I'm adding complexity. So I try to make this chart as simple as possible. This is just to have an idea of, like a visual idea of how complex your software is. You can also use it for detecting circular dependencies, which is usually a sign of something that is complex and might be written in a different way. The tool, by the way, the tool is called Match, and I recommend it because it's really interesting to see your software in a different way than just lines of code. All right, that's enough talking. I'm going to show you a little bit of demo about how the tool works and what you can do with it. So I'm switching to my IDE. First of all, I have my Testy tool checked out here, and as I mentioned before, the test tool is tested in itself. So all Testy tools are written in Testy. So what I'm going to do is to run my test. And if I run my test, I got 213 tests passed. That's the number of tests that I have right now. This is the summary. You can see how many tests were passed. If there are failures, we will see them here. And at the very beginning, you will see like a starting message with all the configuration values. In this case, I'm not doing a fail fast thing, and I'm running the test in random order. So I'm going to show you an example that I made for this conference. It's how to write a test using this tool. So writing test is as easy as calling a test function that gets imported from our Testy module. The test receives a name and a function that is the test body, pretty much similar to other testing tools. If you use Jest or if you use Mocha, it's exactly the same. Name and a function representing the body, and tests are grouped inside the suite. So that's inside the function that is all the suite body, and you can write many tests in a test suite, as you can imagine. As I mentioned before, the test should have at least one assertion, and here I'm making a test very simple, which is creating a cat and a dog with both have a name. So this is the code for cat and dog. Those are pretty simple. They have the same property called name, and I'm asserting that the name of the cat is equal to the name of the dog. So I'm expecting this test to run, so I can do npm test and pass the name of this file, and in this case it just runs the file that I specified, just like other testing tools do. Let's see some things that the tool provides. Let's say that I forget to write this assert. I run my test. So if I run my test, I got an error, and the error says this test doesn't have any assertion. And this is the feedback that students find very helpful when writing tests. So that is one of the unique features that I try to build for this tool. And the other unique feature that I mentioned before is this idea of undetermination, if both things are undefined. So I guess you might experience this issue at some point in your career as a JavaScript developer, where you misspell a feature. Yeah, a property, right? You have a typo, and this doesn't fail in JavaScript. This returns undefined. If I end up with something like this, most of the testing tools will report this as a success, because this will be undefined and this will be undefined, and the equality is undefined versus undefined. It's okay. Well, this tool doesn't do that. This reports a failure, and the failure says that there is an equality, but the equality it's an undetermination because both parts are undefined. And this is to prevent false positives, because this test is definitely a false positive, because I'm not testing that names are equal. In fact, names can be different, and the test in regular testing tools will pass, right? That's why I implemented this tool, because it's a problem that I see when people start writing tests. It can be confusing to have this type of false positive. Regarding the Fluent interface of assertions, the basic structure is that you have an object that is called assert, where you specify that a particular subject matches a particular expectation, and you can use something like assert that an array is empty, something like this, or include a certain value. It has always the same structure, but you also have some shorter ways to do that, like the one that is right below. So the assert are equal, it's an equivalent way of saying assert that something is equal to another thing. Those are equivalent, and those are all documented. You can check for is null. You can also check for is undefined. There are check for raising an exception, for instance. That's another useful test. Those are all generated using the assert object that you also get imported from the Testy module. So you just need to import the module, grab the assert object to make assertion, switch and test, and I will show you how these pending and fail things work. Let's say that I wanted to mark this test as work in progress because I didn't have time to fix that, so I can use this pending due to a particular reason. So if I run that, you will see that in yellow. This is something that most testing tools do. It's a way to mark tests as it's not a success, it's not an error, it's just a pending, and it gets reported as pending. You can also explicitly fail a test. If you reach to a certain point where you know the test should fail, you can say fail with and give an error message here, and this, as you might expect, it will return a failure. So in summary, you have 5 different states for a test. It can be success, it can be failure if an assertion failed or the fail was called explicitly. It can be error if something is invalid or if an unexpected exception was raised in the middle of the test execution. It can be pending. And there's also another state that is called skipped. That happens when you have the fail fast. So let's say that you run 10 tests and the second one failed. So the remaining 8 tests are skipped. They are not executed at all. That's pretty much the summary of the tool. There are more features, but this is like the overview. I wanted to thank you for watching this talk. If you are interested in the tool, you can visit the repo in GitHub. There's plenty of documentation and issues. I would recommend you for small projects like coding katas or like exercises. If you are teachers and you want to use this tool for teaching, I would love your feedback on that. If you are interested in what I'm doing, you can follow me on Twitter and GitHub. That's it. Thank you so much.